Thank you for, but the session is not begin yet, so you're welcome. Anyways, thank you for reminding me. So 192.168 is going to be your local IP that is allocated by your Wi-Fi router. Whereas the IP address that you see when you look up at, say, what is my IP address, okay, website, that is your IP that is visible to the external world, okay, and that is the IP address of your router itself. Okay, your router has a IP address. So if say when you are getting some packet from elsewhere, okay, you need a destination address, right? Your destination address is your Wi-Fi router, okay, and once your Wi-Fi router gets the um, packet, it knows where to forward, like it knows which device initially initiated that request, like your mobile phone or your computers, and it sends back a request and it forwards the request that it receives to your laptop. Okay, so remember how we discussed in the last class that the whole of internet is nothing but a collection of such local area networks, right? um, it's the same way. So for example, if you are right now you are, say, classroom.vrook.co, right? And which is the provider that is providing us this service, which is the big blue button interface for the video conferencing. Big blue button is the video conferencing tool that we are using right now, all right, which is helping us have this video conference. So now to get packets from this, all right, what your device does is to send requests to this server that is hosting this video conferencing tool, right? And to reach that server, yeah, it is the same with the mobile networks too, right? Mobile networks too work the same way, but it's just that your ISP is going to be your internet service provider, is going to be your mobile network provider, mobile service provider. So, so when you are making requests to this server that is hosting the big blue button server application, is what happens is that your computer initiates a connection, okay, and it sends out a packet. Which now, if you are connected to a Wi-Fi router, the packet is first forwarded to the Wi-Fi router. Okay, now the Wi-Fi router then pings a local router that connects to the uh, that connects you to another router, and it might have multiple hops along the way before it is going to reach reach the server, which is where this application is hosted. Now, so so your whole local area networks interconnected are called your wide area networks, right? And the collection of all the wide area networks are your is the whole internet. So usually it takes, say, you start a ping, it goes to your local service, a router here in your area, then it goes to your regional router. Say for example, in Bangalore we have a region, I use a service called Hathway, and Hathway as a regional router in Bangalore. And after the regional router, it goes to some other router in Mumbai, which again redirects it to uh, another router, which points it again to the server. So it might be some path like that. Okay, so you can have a look at this command. Okay, this is called trace, a command called trace route. Okay, uh, so for example, I'll just type it out to you in the chat. Okay, so traceroute.google.com. You can also use trace path. Okay, both of them are available. For people in Android, use trace path, which is much better. Okay. Um, so what this will do, these two commands will do is it will list out how many hops it is taking, okay, and where all the hops are going before it ultimately reaches the server that you are requesting. So now in our case, we are looking at the Google server, which is going to be regionally located. Google has regional based servers too to have higher ping. So it will just, take two or three parts in your wide area network. Then it will jump into the backbone, which connects, say, from Bombay, Bangalore to Mumbai, or via satellite link, something like that. That is your backbone infrastructure. And before reaching your server, right? So it will list it out. You can go have a look at trace route and trace path. Okay, which both does the same thing. And okay, in if you are using Windows, you have trace RT, okay, which works the same as that. So try any one of these in your devices, and you can find out where your packets are going. All right. So yeah, let's start off with our class today. Okay. So we are going to be working on a lot of things that define the World Wide Web today. So which is the biggest thing out there right now. Okay. Yes. Are you guys able to see this properly? Um, just a minute. Okay. Okay, are you guys able to see this properly? I'm not sure if you are not able to see this properly. Yes, yes. Okay, thank you. Apurva. Okay, so yeah, so what we did in our last class was to cover most of what we talk about the OSI reference model, all right? So the OSI reference model is like a standard model for your communications on the internet, right? And we discussed a lot about this in the last class. Okay, so for example, the first layer in your OSI model is your physical layer, meaning how devices are connected on the internet, right? So, like the Ethernet cables or your Wi-Fi routers that communicate via the radio wave signals, and so on and so forth. So, all of these, the physical connections, like your Ethernet boards, your Wi-Fi router boards, your Wi-Fi cards, all of the all of them make the first layer of your connection towards data sharing, which is the physical layer. All right. Upon that, you have the data link layer, which we discussed, which is in the last class, which is your MAC address, your router MAC address, and so on, which is your physical addressing of computers and systems. Right. Um, on top of that layer is your network layer, where your addresses such as IP addresses and your connections, IPv6 or different types of protocols reside upon. Okay, for determining the path or routings or all such algorithms. And on so So these three are your, initial, physical data and your network layers. So they are all a combination of your hardwares and softwares, and everything on top of these are your software layers, right? Like the fourth one is your transport layer, okay, which is basically what your connections are, like your TCP over IP connection or your UDP connection, where your connections are being connected from end to end, and your packets are being transmitted, and you're getting packets with loss or without loss, or understanding what the packet or how in which order they are, right? And so, and top of that is your sessions layer, where a connection is established, okay, say in TCP, and you transmit all the package before you connect, you close up the line. So every time, so right now we are in a session, right? We are having a video stream, and to receive a video stream much smoothly, what you need to have is a continuous flow of packets, okay, that you are getting. And so that you need to have a stable connection. So how this is working is that I have a stable connection to the server, okay, which is running this application, and that is called a session, right? And now you guys are also connected the same way to the server, and you're sharing a session with the server, which is transmitting you continuous packets of data, right? And that makes up your session layer, right? And that's one of the best examples. Yeah, and it works in the same way when you're watching a video on YouTube. When you're watching a video on YouTube, you look at uh, what your phone or your computer does is it opens a TCP connection, okay, and it makes a session so that every packets that you are receiving are saved in a continuous flow, and it only closes the session, okay, once some amount of packets are received and saved with this. And if you can remember, you get buffering, right? And so so when you look at how videos load, you see it moves like it does not load smoothly, but it loads in blocks, okay. And every block is going to be a session over there in your video loading. And once that block is completed, it opens up a new session, you just don't clog up the line. Say if you are watching a very big video that is an hour long, and having a session for that long is going to clog up the internet, because a lot of people are using the same services, same network, same paths as you, right? You don't want to clog up their paths too. So that's why you have sessions that are breaking up. So that makes your sessions layer, and on top of that are your presentation, or your app, and then your application layer. So all of these make up your you know software, are completely software related. And but sometimes you use in your application, all of these are hosted on a server, like your SMTP is hosted on a server, your domain name system is you're going to be hosted on a server, and all of these are going to be hosted on a server, your applications. So your presentations are basically your files that you're going to be transferring, and your connections of your sockets, or your you know, videos, MP4s, and your applications layers are your SMTP servers, and your email services, Instagram, Facebook, and all of those make up your, even Big Blue Button that we are using right now is an application layer. All application layers are written using HTML. No, Mahesh, not all application layers are written using HTML, because your SMTP server is not written in HTML, right? And Instagram is not written in HTML. For example, Django, which you use in Python programming, Django is, you can use it to build websites, which does not require that much of HTML tools at all. Yes. So application layer might be written in a language that can represent files on your there. So can I know how an IP address can pinpoint the device location? So the device So this is a good question, Shashank. Okay. Um, there are two answers. Okay. Can I know how? Uh, yes and a no. Is a answer that is weird enough in the way. Right? So let's go back to the IP address you provided, right? So you provided the IP address 203.192, right? And 204.83, right? So let's forget the second, let's consider only the first two, and let's forget the 204.82. Okay. So the first two are usually what your uh, service provider, internet service provider assigns, right? And your service provider, you know, assigns these based on locations itself, physical locations, right? So, for example, I stay at Baswangudi Tyagaraja Nagar, right? And for me, my IP address is something like 115.99 for one 115.99.52.81. Let me just put it over here in the chat, right? That's my IP address, my router's IP address, right? And the 115.99 is assigned by my ISP, okay, to this locality, okay, and the 52.81 is given dynamically via a program that runs on your router or your devices that connects to this service provider. And mine is a fiber net connection, so I definitely need a router to connect to the internet. So my router assigns, takes requests. If it randomly picks an IP address as the ISP provider, it is okay, which is again a software over there that is checking it. And if no other device is using that IP address, it just assigns it to me, right? So that's what you can number. The best thing you can identify from your IP address is in what area that IP address is in. But it can't give you the information of which device or whose device or where physically that device is located at. So, does that answer your question? So, I guess I have got to that point. But yeah, usually that is the problem a lot of people face in huge offices when something gets hacked, and that some IP address is what how they are linked to, but you can't just go unplug one Wi-Fi router and get it disconnected, because it's not how it works. So you can't physically locate an object using your IP address. Okay, moving on. So any more questions on your OSI reference model? So most of the things that handle sessions is what we covered yesterday, from your physical layer to your sessions layer, and today we are going to be mostly covering on the presentation or the application layer, right? And so any questions until now? Any doubts you can ask now, or else I'll move on to the next slide, right? Okay, then. um, if not, I don't see any questions, so yeah. So I'm sure, see, a lot of you have come across this thing too, right? Um, the World Wide Web and the internet. Just a minute. Huh. So even though, see, people use the words interchangeably, okay, the internet or the World Wide Web, like the web in short, right? So they are two different things that, I'm sorry, that they are two different things, okay, altogether. So your internet is what is how computers communicate. That's how they send packages, and that's how the Lyceum, they make sessions, all your physical layer and everything, right? And the OSI is actually a model for your the whole internet, right? But your World Wide Web is an application that runs on top of the internet. Okay. So this is a bit confusing. I understand that too. Right. So we'll have a look at that. Our whole of today's class is going to be understanding of how the World Wide Web works, right? And how it changed internet as we know it. Okay. Uh, so first of all, see, for communicating, okay. So on the internet, you don't need any kind of a special application. You can write some piece of code that can send data over to you, some other computer in some other location, right? And you can just send data, and you can design data however you want. But the World Wide Web is a special kind of an application that requires a special kind of an access tool, such as the web browsers or applications that post such requests. Okay, like the web browsers. Okay. Um, so to give you a first understanding, you can just go out in your open up your terminal, and you can do a trace route, or write a ping. Okay, you know what a ping is, right? So a ping is that you can just ping a server if to see if the server is responding or not, right? So you can just go and ping the server, and still the application runs, and see that is uh, the that is what the internet works on. So you can just so how do I put it? So while using a ping, you don't need some kind of a special kind of an interface, and it is not working on the World Wide Web, but it is rather working on the internet. But the World Wide Web is the application that where you have to have special kind of requests, such as applications such as web browsers or other such applications to access. So we first have a look how the World Wide Web, or the web in short, is structured. You know, by looking at what is called as a web page. Right. So you can, yeah, that's the whole thing. So you can summarize the whole World Wide Web or the web by generally a single page. Okay. So I have not included hyperlink here, but yes. So a single page, like in just a text document. Okay, just consider a text document. Okay, so uh, just say this is the document that we are viewing right now, which is titled web pages, and it is what some text over here, right? And you have seen these in common things. So uh, you can have text, and what you do is that, say, if you have some kind of a knowledge sharing session, right? So for example, the best example of a better web pages are Wikipedia, right? So if you go and visit Wikipedia right now, so let me just share you a page on Wikipedia so that you can have a look at that. Okay, which is this page on the internet, right? And if you just, let's go and visit it together and see the pages of it, right? Which we can okay, so that we can understand together. Now when you open the Wikipedia page, now this page is on internet, right? And you see it has got definition of what the internet is. The internet is a global system of interconnected computer networks that uses internet protocol suite to communicate between networks and devices, right? I mean, the first sentence, this is what you're looking at, right? But you see these things. The first thing that is being highlighted in the first sentence is computer networks and the internet protocol. And when you go and click on it, okay, it redirects you to another page, right? So what these are called hyperlinks. Okay, so hyperlinks are a way in documents, and not just on the internet, but in say anything in machines generally to speak, right? So where once knowing something, right? Once you know some kind of an information, if you say here in our context, you know about computer networks and you already have understood the information of computer networks, you can refer that information in some other context or some other, or using it to define something else. You can just go back and refer to it by creating a link for the new information you created and the old information that you know, right? And the link that you connect, that make by citing, okay, computer networks, I use it to define what internet is called, right? And in the internet document, you say, okay, if you want to look on computer networks, you just have to click on it and it will go to, it will tell you the information about computer networks, right? And this link is what you call as the hyperlink, which gives you the information that is connected to you. And this way, what you can do is like you can create a network of knowledge, right? And this is what we, sorry, this is what we refer to as the web of knowledges, right? So you can have, uh, you can go to the next page, and here in the next page we have, if you click on computer networks, you have something that is a definition of the computer network in the first line, and you have computers, refer to it, and you can click on computers and it will take you another page. And there you have, if you look at, I clicked on the computers page, and in that page you can go and see the definition of the computers, and here there's a link to something called as
Just
sequences.
a minute, Kanta. We are not able to see your screen.
Oh, oh, okay, let me just share you the screen again. Thank you for telling me that. I just shared the screen, I thought it was visible. Okay. You guys can tell me up. It doesn't have to be Varun every time is telling me that we are not able to see the screen too. Right? Uh, oh, is it coming now? I'm just getting a loading signal right now. Um,
Yes, got it, Kanta.
okay, yes, fine. So we can go here and just click on computer networks. It leads me to another
Can
page.
you zoom in a little bit? Like little bit.
Okay, is this fine?
Yes, okay, cool.
Okay, so now I can come. This just pops it up because this Wikipedia is good in advance. But this again leads you to another, you know, information to another web page on computers. Okay, and you can see that computer is again connected to something called as sequences and arithmetic or logic, and computer programming. And you can just keep on clicking on, and it would lead you to a lot of places, and eventually it actually leads to something called as philosophy. And this is the last time I checked. Clicking the first links on Wikipedia pages, uh, leads you to something called as something in philosophy, right? So basically, so see, you understand, when you look at this, you kind of get the idea, right? So you have a text, okay, and that text is connected to some other information page, and that page is connected to some other information page. And it is not just connected in line. Other pages refer to other pages. Okay, and it kind of let me just so it kind of forms a network. Okay, and the same way how internet forms a network of devices. Okay, uh, the web pages form a, a network of pages of informations, right? And that's how you get a whole network of information, and this is what you called as what you essentially go up to calling as the world wide web, right? Which is the interconnection of information, or interconnections of things, okay, that are clickable and that you can visit information related to that in a separate document or a page or an image or a video or whatever that is available on the internet. And this whole network forms above the internet, the application layer of the internet, and is called as the World Wide Web. So, so the texts that contain hyperlinks, all right, is what you call as the hypertext. Okay, so you so when so the presentation you are looking right now is not a hypertext, because this page does not have any kind of a link, right? You don't have any kind of a clickable link here in this text. Maybe I should have added some. I guess it is there in one of the next pages. So that is not a hyperlink too. Okay, so so these things are just text, but when your text carries a clickable link which can lead to information of another page, that text is called as hypertext in general context, and that's how we started naming it. Okay, so so now we know that the understand what hypertexts are. The web pages that we visited on Wikipedia, right, are your most common types of hypertext documents, right? They have clickable links, okay, and you can click on them and you can, move on to some other place, right? But this is how there's the problem of this, right? You see, every information is unique, all right, and every page is going to be unique, right? It is going to contain some kind of an information. It is going to contain, say, for example, we looked at internet, and internet is going to have the internet web page is going to have information on information on internet, okay, and and if you click on the link that first appears is what you call as a computer network, and that computer network page has the information on computer networks. So you have to have a way of looking up these pages, right? Yeah, naming these pages, right? So the internet page has to have a unique name, okay, and the one that we looked at was hosted by Wikipedia. Okay, Wikipedia is the organization that hosts the pages over there, and uh, and they have wikipedia.com/internet or whatever we saw, right? See here. Um, anyways, so so to access those informations, those unique pages or the pages, we need some kind of a unique address, okay, and on the web this unique address is known as the uniform resource locator. So all your web pages are resources that are located on the web, which you can go and locate, okay, by having a unique address, and these are what you call as URLs. And right now you are connected to this video conference via this URL called classroom.vrook.co/html5 client/join, and you have a session token which is randomly generated for the session. And in the same way, an example URL is our URL of our course docs, which again, let me give you the link of that if you haven't already accessed it. All right. So, so this again is a URL which specifies, okay, what is, I mean, where can we find this web page? Okay. Now we'll jump back to the session that we had while closing the session one the last time. Right? In the last session, what we had was the last thing that we discussed was the domain names system, right? So the domain name system is a way of mapping names. Like see here, the example is lyceum-eot.github.io, okay, which is a domain name, okay, which is supported by GitHub, all right. And the this conference that we are having right now is on classroom.vrub.co, which is again a domain name, okay. And to request these pages, what typically happens is your computer opens a connection to a domain name server, okay, server which is hosting DNS, okay. So what it does is a DNS lookup. So it requests a DNS that is either, a lot of people host DNS services, okay, and it requests a DNS, and it what when it has a DNS lookup, the DNS server recognizes what is your domain name, and it provides you back with a URL. And that's simple as that. That's what your DNS servers do. That was what your domain name system works on. So it looks up a name, matches it to a IP, and returns you that IP, right? And you get the IP down to your computer. Now, once you get the IP, what you do, okay, when you want to look up the page like lyceum.eod.github course docs and coursework, right? Your computer initiates a TCP connection, because remember, this is going to be a TCP connection because we want the whole web page, and we don't want web page that is missing some information, right? So we want to have a TCP connection, and also we know that we are going to receive packets that are going to be broken down, and you know in a lot of small packets, right? So so once you get your IP address, your computer connects to the web server, okay, and it usually connects to the port 18 web servers, because in web servers the default port that is open to serve web pages is your port 80, okay. Some might use different, but port 80 is going to be your default port open for HTTP connections. Okay, HTTP connections. We'll get to what HTTP is in the next thing. Okay, and you will have a connection established, and you will have uh, you will request some kind of a web page, and that is what you will get from the web server, the whole pages. So we'll see how that serving of the pages happen before. So yeah, so what happened, so now looking back at this thing, right? So I'll ask you a general question here before we start moving on. So we understand your domain names, right? We understand say what, say classroom.vrub.co is what that is, or what lyceum-eot.github.io is, or say what wikipedia.org is, right? Those are domain names, right? But when you look at things like this, okay, for example, things like this, okay, these things, what is your guess on what these things are? Now, guys, I want you to have a look at it. Give it a thought. What are these things? Say See, this is your domain name. Okay. Okay. And when you get this, okay, what it does is it requests you an IP address. It gets you back an IP address. But what are these things after your domain name? So anything before is going to be your subdomain names. So this is a subdomain name essentially under github.io, and github.io is your, yeah. Yeah, Pramod. Subdomain name is this. See here. Lyceum EOT is your subdomain name. github.io is your domain name in this case. Okay. But what we are looking at as this. Oh, Mahesh. So yes, Mahesh and Jashwant, you're close to the answer, but Mahesh, that is what is somewhat right. It is what directories or what kind of pages are located in which kind of directories, or where on the server is what on the web server, or where the web server should look for those kind of documents. Yes, you're right, Manoj. So that's what these things are. Right? So that's what these things are. Uh-huh. So once your computer, connects to the web server by looking at the domain name or subdomain name, it gets you back a connection, and once the connection is established with your web server, okay, the next thing we got to do is to request the web page that is holding in the information. Okay, and the protocol, okay, that we use to request these web pages, right? The protocol that is used to request these web pages are called your hypertext transfer protocol, and that's what HTTP stands for, right? And you can have a look at this in every kind of a link that you'll be looking on the internet. Okay, so there are different types of other protocols too, like your FTP protocol, which is going to be your file transfer protocol. All right, but what is generally used right now to link web pages in broadly the internet is your hypertext transfer protocol, right? And when the HTTP was originally documented back in 1991, it had only one command, right? And that's all that was needed back then. Okay, and that was get command, right? Uh, the get command just simply does this. Yeah, once you can establish your connection with your web server, okay, you send a get. Okay, you send this command get, courses dot coursework, right? And when you do that, all right, you get back the web page that is holding this document. And if you visit that page, all right, oh, I have closed that page. Okay, so now you can see that this is a web page that is, has hyperlinks of of class recordings. It has coursework, and you can just have a look at it, and it is going to be a web page with hyperlinks, and which is formatted in the hypertext format, right? So when you send the get request, your web servers serve you the pages that was requested. Now HTTP also, the initial version didn't have the status codes, but uh, the version that came after the initial versions had what are called as status codes, right? And once you request some kind of a page, okay, and say this path, okay, is there, like get course docs dash docs dot coursework. And if you just, instead of requesting that, you request something like lyceum dash eot dot github dot io slash some Jablish, okay, something like HTTP or some kind of a word that you just add after the subdomain name, right? It will it knows that there is no file in that path, right? So it will return you. It has to return you some kind of an error. Okay, saying okay, this is not the this page that you requested does not exist. But if the page actually exists, like the course docs dash docs dot coursework, it will by default send you 200 status code, and this will be sent in the package that you will be receiving. Okay, uh, and the status code, and once your web browser receives the status code 200, it will start uh, and it will automatically render. And then you have the web page path does not exist, you will probably get a 404 error, and there are a lot of other 400 errors that are client based errors. And say if your databases are not connected on your web servers, it will usually lead up to a 500 error, hundreds error. And there are other uh, status code errors that you'll be getting when you are trying to initiate a connection with the web server and trying to get something from that, right? And nowadays, your web pages are not just containing your hyperlinks, but it contains more. So we'll have a look at what those more things are. Okay, but before that, we'll come back to what is initiative thing, right? So now, see, you just have text. You can just write down texts on the internet, but what you need it, okay, to mark up these texts with your hypertext elements, like your hyperlinks or images or everything, is you needed a language that does exactly this, right? And that was how hypertext markup language, or your HTML, was formed, right? And your HTML is the language that what you typically use to do all of these, to say put hyperlinks or in texts, and or an embedded image, or most of the pages in the web right now has a lot of HTML elements. And see, this right now what we the original version was created back in 1990s, which was uh, actually done by Sir Tim Berners-Lee. Okay, so I guess we have about him. Okay, we'll talk about it in the next page. Okay, but he was the person who wrote this, and initially it had only 18 tags. Okay, and I'm sure everybody here has their fair exposure to HTML, right? So right now the HTML5 version, and the one that we are running right now, the big blue button, the client that you are using right now, and I don't think anybody is using the big blue button application, but everybody is logging through the browser, and which is using an HTML5 client, which has more than 500 stacks. Okay, so so here's the quick poll: how many of you guys have written documents in HTML? I'm sure HTML was there in your 12th, right? You guys do have it in 12th. If you had taken up computer science in 12th, I guess you had it. But even if so, it is not there. No, in first PU. Oh, even in first PU. Makes sense. So I see a lot of people. I see more than six people saying no, they have not written in high HTML text. Huh. Shashank, you had it in 10th also. It was a nice school then. Yeah, I guess I also remember that. I remember, I don't know for what reasons we were forced to read HTML codes. I guess in 7th or 8th. Akhilesh probably remembers that. Yeah, I are from the same school. So Um, yeah, some schools teach you pretty early on. Yeah, but even if it's basics, they let you teach. Uh, they make sure that you memorize every kind of the whole program and dump it on to some kind of an exam. So, yeah, right now in the poll, I see almost what 7 people saying no, they have not written in hypertext document. So then we are going to do that today, right now. Come on, join with me for those people who want to write a HTML document right now. We'll write a very basic HTML document before we start moving on with this lecture, so that you guys who are saying no can take part in it too. Come on, now fire up your terminals. I'll share you mine. Uh, Let me just clear it. It's window, and you are able to see that. Okay. Yeah. Let me just publish this result. Okay. Just a quick poll again. Okay. How many of you are still using Termex right now? Using Termex. Oh, it is 11. 11 people are using. Oh, 11 people are using a computer, and I see 6 people. Again, fast again. Anybody else is using Termex? Because you guys need to get some special instructions to render your HTML type. Because Termex does not, you know, it stores your files in a weird location, so you have to CD differently. Can you please zoom? Let me just try. Is that better, Pramod? Is that better, Varun? Yeah, yeah. Thank you. So
Yes, Kanta.
yeah, sure.